Hello everyone. Today we are going to do Pre-Calc Lesson 45, Conditional Permutations and Two Variable Analysis with a Graphing Calculator. This is when it becomes extremely important. You have a graphing calculator and you know how to use it. I'm going to demonstrate with a TI-83 today. I will give out a handout that will help you guys if you have a different calculator. Okay? But first, let's talk about conditional permutations. For conditional permutations, there's no formula. Okay, so like in our other permutations, we had a formula. The key to this, as with most things, is to draw a diagram. So let's just jump into some examples. Example 1, how many odd counting numbers can be formed from the digits 3, 4, and 5 if no repetition is permitted. Okay, so there's quite a few things that we have to look at in this. The main thing we have to know is that it is going to be an odd counting number, right? So what we want is, if it's a counting number, let's first look at the couple one-digit cases. One-digit cases, for it to be a counting number, right? It can be 3 or 5. So we have two options. Now let's look at two-digit. Okay, for this second option, for it to be an odd number, then it has to have odd, right? It has to have an odd ending, so 3 or 5. So we have two options here. And if we've used one of our options, we only have two other options left because it says no repetition is permitted. So for one digit, we have a total of 2 options. For 2 digits, we have a total of 4 options. Now let's look at 3 digits. Okay, again, we know that this is going to be 2. This is 3-digit. We know that this is going to be 2 because it either has to be 3 or 5. And if that's true, again, this is 2. If we use 3, then we can choose 4 or 5. If we use 5, we can choose 3 or 4. And then this option is only 1 because no repetition is permitted. So again, I do 1 times 2 times 2, which gives me 4. And then I add up all of these. 2 plus 4 plus 4 gives me 10 possible ways. Okay, it's a little different than what we've done before because we have a condition on it. It's not extremely different though. Let's do another example. Find the number of odd 3-digit counting numbers that are less than 600. Okay, so let's look at all of our digits. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, now we're doing a 3-digit counting number. So we're gonna have 3 boxes. Let's look at this last box first because we know that it is going to be odd. So our odd options, we have 1, 3, 5, 7, and 9. So 1, 2, 3, 4, 5 different options that can go here. Now, it doesn't say anything about repetition, but we know that we have this stipulation, less than 600. So in this box, we cannot have 0, right? Because then it wouldn't be a 3-digit counting number. We cannot have less than 600 means we cannot have 600, 700, 800, or 900, meaning we have 1, 2, 3, 4, 5 options for this first number. And the middle number, it can be all 10 of the digits. It really doesn't matter. So we do 5 times 10 times 5, which gives us 250 3-digit counting numbers less than 600. Okay, let's do another example. Example 3, how many different, keyword, different 4-digit odd counting numbers can be formed if no repetition is allowed. Okay, now if it says how many different, we already know that no repetition can be allowed, but they repeat it for us just to make sure we're clear. Now we want a 4-digit odd counting number. So again, if it's going to be odd, we have 5 options for our very last number. Okay, and if we look at our first number, okay, we know it cannot be 0, because if it did, then it wouldn't be a 4-digit counting number. And we know that we already used an option here, so that eliminates 2. We have 8 options. Okay, then I've used one option here, so I have 8 left, and then I have 7 left here. And I multiply all of them, I get 2,240 different odd digit counting numbers. Okay, let's do example 4. We have 5 math books and 5 English books on a shelf. How many permutations are possible if math books and English books must be kept together? I want you to try this for a moment on your own. Okay, see if you can work it out. All right, so I hope you got a good chance to do it. What you should have is you should have these 10 different boxes. Okay, so 5, 6, 7, 8, 9, 10. Okay, we'll have 5 books, 1, 2, 3, 4, 5, that are math, and 5 that are English. Okay, and we know that we obviously cannot have repetition. So we have 5, 4, 3, 2, 1 math books, and we have 5, 4, 3, 2, 1 English books. Right? And if we do this, we get 5 factorial times 5 factorial, and that gives me, let me do it in the calculator, excuse me, 14,400. Now, this is if math comes first. We could also do it if English comes first, right? If these 5 are English and these 5 are math, then it would again be 5 factorial times 5 factorial. And we would have to add these two together to get my total options, which would be 28,800. Okay? All right. Now, let's move on and talk about 2 variable analysis. VAR analysis. What this is called is linear regression, which is the line of best fit. Now, we have done this before where you are given a graph and given a line, and you are told to find the equation of the line of best fit by hand. What's going to happen now, which I'm going to show you in example 6, you are going to be given a chart. So in this case, our chart is going to be here, silver and gold. Okay, we'll have 82, 87, 97, 107, and 107. And silver will have 9.5, 5.5, 7.5, 1.5, and 4.6. And your book will give you the graph. I'm not going to draw the graph now. And it will be asking you to find the line of best fit. Okay, so this we're going to do on the calculator. So I'm going to show you. So on my calculator, if you go here where it says list and stat, I'm going to hit stat, and you will see where it comes up with edit. I press enter. Now it comes up with these lists, list 1 and list 2. If you already have something in it, you go up to where the list is highlighted, press clear, enter, go over to where your next list is highlighted, clear, enter, and you are going to enter the 2 lists I gave you. So the first list here, we'll have 82, 87, 97, 107, and 107. List 1 is often your independent variable. List 2 is your dependent variable. So make sure you enter it that way. Then we'll have 9.5, 5.5, 7.5, 1.5, and 4.6. Your line values should add up. Okay, then you hit stat again, go over to calc, and option 4 says lin reg. I'm going to hit that. You should see lin reg or linear regression show up on your calculator. You press enter again and it gives you this. Okay, now if you look here, I have an R equals value. You might not have that. If you don't have that, what you need to do is press second 0 to go to catalog, and you have to scroll all the way down to diagnostics. So here you can have diagnostic off or diagnostic on. I'm going to hit diagnostic on, enter, and then I'm going to do the linear regression again, and then you should have your R. Okay. It didn't like my R. Hold on. Make sure my lists are right. This one's wrong. Okay, so here's my linear regression. Now it's a linear regression, meaning it's in the form of the line. So we're looking for y equals ax plus b. It gives me the a. So I'll have y is, my a is my slope, negative 0.21x, plus my b, which is 25.64. This is the equation of my line. Now we have this r. I'm going to write down what the r is, and I'm going to talk about it. Okay, so this is my r. What we call r is our correlation coefficient. That is the r. And what r is for us, so if all our data lies exactly on the line, so if I was to have my line of best fit exactly matched all of my data, then r is plus or minus 1. Okay? For scientific data, okay, we want the desirable r, we want it to either be in between -1 and -0.9 or 0.9 and 1. What this tells me is that there is a good correlation. Meaning my R is a good R. It does what we want it to do. Okay? If R is outside of this, it's not a good correlation. Okay? Now, just for the sake of interesting, for social sciences, R is in between -1 and -0.7, or 0.7 and 1. This is typically what I want you to know. I want you to know the scientific data. Okay, you don't need to know the social sciences, it's just kind of a fun added thing. So you need to have, whenever you do these problems, your graphing calculator. You put these lists in, you need to find the line of best fit, and then you will be asked to find your R. All right, that is all for now. We will see you tomorrow in class.